we started using it in 2014 with just a few Scala services alongside our main Python backend. But now we've got 98 active Scala projects. We use it across data engineering, product recommendations, analysis, machine learning, loads of different stuff. So the way this session is going to run is we're going to quickly do an introduction just to some key functional programming concepts. And the general idea that we're going to implement is that we model information about products sold on Depop, apply some logic to it, and then pass it to a front end for display to users. We're going to make sure that you've got all your environments set up so that you can attempt the exercises. We've got 4 exercises to do, so for each one we'll introduce it with some slides, explain anything you need to know, and then we'll go into breakout rooms for about 15 minutes where you can attempt to solve the exercises and we'll check in and help you out if you get stuck. And then we'll come back and go through the solutions and move on to the next exercise. And please interrupt us anytime if you've got questions so we're not just talking at you. And we'll have a break about halfway through. And so the main gist of this is functional programming and just a little bit of history. So it goes as far back to 1958 with Lisp, which was one of the first high-level programming languages, and it hasn't really been popular in the mainstream until about the last 10 years, when as languages like Scala have got more popular, other languages have started to integrate functional features as well.
It's not really clear what a functional programming language is, but all of them have one thing in common. The central building block is the pure function. A pure function is a computation that if you give it some arguments, it will always evaluate to exactly the same result. And it's very important that it also has no side effect. To illustrate that, let's have a look at a counterexample first. Here's a bit of Scala where we have a variable I, and every time we call the function increment, we call the function count, you see here, it will increment the counter and therefore have a different result. So the first time we call count, it outputs 1. The second time it outputs 2. And we'll look more at functions later, at how they are defined. And this is an example of a pure function. It changes the first element or the head of a list of integers. If we give it a new head x and a list of integers xs, we replace the first element. We replace the first element by combining x with the tail, so that's everything except the first element of the input list. But it's important to note, since our function has to be pure, that the original list doesn't change, but we reference the list starting from the second element. The mental model for functional programming is that everything evaluates from left to right, and because there is no side effects, that is everything you need to know to reason about the program. And this is called referential transparency. In Scala, we have a certain amount of data types that are already defined, such as integers and strings. But if you want to combine them, we can do this by making case classes. Here you see a point, which is a 2D coordinate with an x coordinate as an integer and a y coordinate. Inside the class, we define some functions about its behavior. For example, move here. It creates a new point that is shifted by dx and dy from the current point, creating a new point, and again, leaving the original point intact. We also have traits. Traits are a way to define a contract for types. In here we see the trait iterator. It defines some functions that are necessary, but without implementation. And we see a class int iterator, which is a implementation of iterator. And the class implements the behavior by saying that int iterator extends iterator. int iterator also becomes an iterator. And here, a closer look at a function. We start a function declaration with the keyword def, then the name, and a parameter list. In the parameter list, we have parameters, which are again a name, and after a colon, the type, followed by a colon and the type for the function. Then we have the body of the function, where we have local state, optionally, which can only be seen inside the curly braces, and the function evaluates to the last expression of the body. So here that would be x. Here there is sum, which is x plus y.
Okay, so this is the moment where we want to make sure that everybody's got to the point where they're ready. They've got Scala installed, clone the repo, you can run the tests, you can hopefully run our application, go to localhost port 9009 in a browser, and you'll hopefully be able to see our lovely approximation of Depop here. It looks better in real life. And yeah, so shout if you're having any problems. I'm not sure how we're gonna know that everybody's
just as
ready
an
or
indication.
not.
Should we?
Give us a thumbs up to show us if you've installed everything, so that we have an idea how far along we are.
What were you going to say, Charlene?
I was going to say, should we go into breakout rooms, or do you think we should? In fact, this bit's probably just getting set up, isn't it? So it's probably best to stay here. Nkachi says she's got some issues. What issues are you having, Nkachi?
So it's saying at the bottom now, indexing JDK11. When I went to when I was doing this setup, Java version didn't bring anything up, so I guess that's related to that, but that seems to be sorted now. And now it says no Scala SDK and module. And then I have nothing to select for that when it says set up Scala SDK.
Does it give you a little window or a little prompt to
Yeah, it does. I mean, it says
download or install?
It says setup, and then it says use library. There's no library to select, and library is not specified.
And is there a button to add an SDK in that prompt?
There's one to create one.
Yeah.
And then it says download, and then there's all these options, I guess, like different versions. And the automatic one is 2.13.3, which I guess is the most recent one. So should I click OK?
Yeah.
Yeah.
Okay. I've clicked OK now. I think that should be it. I don't know how I would run the tests.
So you can open up the little terminal at the bottom of the window and type SBT test.
What was that? Sorry. Let me see if I can see. So it says SBT test.
Mm-hmm.
It's saying it's not recognized.
So it doesn't recognize SBT.
Yeah. This is what I was. This is.
It's saying something about extracting project structure from SVT, so I'm guessing that needs to finish before I can like run the tests or like run a local host.
Yeah, the first time you run it, it will take quite a long time to just sort itself out.
Yeah, it's saying 6 minutes now, so I'll just wait.
Yeah, the environment IntelliJ has its own approximation of SVT. A lot of things that you can do, and running it in the terminal is separate from that. So you might be able to do a lot without having SVT installed.
Yeah, another way of running the tests is to go to the actual file where the tests are. And they're in a file called exercisespec.scala, and then you can like right click within IntelliJ, and there's a little green arrow button to run the tests.
Is anybody else having any issues? So
if I already
I'm just saying that there's.
I was going to say, I already have IntelliJ. Can I just add Scala as a plugin?
Yep.
And how would I do that? Because I'm new to IntelliJ. So is there a menu?
If you go to the top, there will be a preferences or a settings.
Wait a second, okay.
And from there you can find plugins, and you can find Scala.
Okay, thank you.
How's everyone doing? Anything good happening?
How is everyone getting on?
I don't know if I can run the tests either.
Which way were you running the tests?
I tried the SBT test command and it said the command wasn't found.
Can you try opening the file called exercise spec, and if you right click inside it, and there should be like a green arrow that lets you run it. Hopefully it'll work that way.
Which folder is that under?
It will be something like test, but I think it might be inside another folder called Scala.
Oh yeah, oh cool. So I've got that, and then
Jennifer, what's the green arrow that you're expecting? Is there supposed? What's the green arrow?
I can show on my screen if that helps. So you should be able to open up the test file here. It's called exercise spec. And then if you right click, there's a run exercise spec button, hopefully.
And there's no need to be alarmed by all the red.
I'm actually quite excited to be doing anything code related. I've not done any code for so long. I'm really excited.
Was anyone... Sorry.
I have Java installed, but I think this is probably something somebody said previously. So I've got the Java, so it's saying I don't have Scala SDKs installed, and I thought I'd done that when I did the plugin, but it's not recognizing it.
Are you on a Mac or on a...
Always Mac, always.
I did brew install SBT.
Okay.
I think it was that, and that just worked. Yeah, probably shouldn't say that, but yeah, it seemed to just work, and now I'm doing the... So brew install SBT, and I think that installs the Scala test package.
So SBT is like the Scala build tool.
Okay.
I was trying to guess what it could mean.
Good guess.
And you said you don't. It's asking for Scala somewhere. Where is it asking you?
So I don't know if it's useful. Can I just share my screen?
Yeah.
I don't know if that's useful.
Yeah, I'll stop sharing.
There might be others having the same problem.
So I get here and like all the code is there and stuff, but then it's these two things.
Sorry to interrupt you. It looks like you've shared only a tiny window with the tip of the day.
Oh.
Instead of the whole screen.
What have I shared? Oops, yeah.
Only a single window.
And I work in technology. That's just, yeah. We don't tell anyone about that. Okay, cool. What can you see now?
Now we can see your desktop.
Cool. Okay, so I downloaded the project and that was all good. And I've got this, but like, I think it was like Jennifer said, like usually when you get the test, you get the red arrows where you can just run the individual tests and stuff like that. And I don't have that. And then I have these two things up here. And like, I already installed Scala before, but it doesn't seem to have picked anything up.
So what happens if you click set up JDK and set up Scala SDK?
So I mean, like it's, yeah.
Okay, what about JDK?
Cool.
Yes, if we go 1.8 with the Java version.
And you see there's in progress in the bottom. So that's why the warning is still there in the top.
Ah, sweet. Okay, so now it's doing stuff. And then if we do this again.
There's no libraries currently available. If you click create. And then download. And let's see if there's a...
Oh, I think we wanted 2.13.
Oh,
yeah.
Sorry. I'm going to try not to swear. So to click down, okay, oh, it's already doing stuff.
You might be able to just downgrade your project instead of downloading another one. I don't know if that would be quicker. We'll see how long this takes.
So what can I, when you say downgrade the project, what do you mean in terms of Java?
In terms of the Scala version we're asking for. Oh no, that was quite quick. So let's try, should we try again and click create?
So is that version still okay? Or downgrade it?
If you click create, and then we should be able to find 2.13 instead. So if you go download again, there isn't 2.13. Okay, never mind. Ignore me. Let's see what happens with this. Okay,
cool. Yeah. Let's cancel that. Cancel, go away. Go away. Okay, and then just get rid of that. And so I should be able to now run the SBT.
Can you, if you right click in these tests now, does it give you the option to run? No, it doesn't.
Oh, 1 minute. So we've got new configuration files. Let's put
that. Maybe if you try SBT test, and if that doesn't work, you can brew install SBT like Charlene said.
Yeah, that looks right.
Yeah, and this may take some time. Cool. All right, I'll stop sharing now. Thanks.
No worries.
So SBT finished installing for me, but running the commands in the terminal still isn't working. Did you suggest trying to install SBT by brew or something?
Yeah, Charlene said she installed it with brew and that worked for her. What's happening when you try and run SBT test?
I can do a screen share then quickly.
Yeah, sure.
Yeah, I think this is it. Right, so it should be sharing now, and like running test says that it's not found. There is this, however, I don't think this is the right place for doing it, so I don't have it. Right click, I don't have the option either, and this is grayed out, so I can't do anything at the moment.
Okay.
Actually, in this window, if you type run instead of the SBT, so omit the SBT, then I think that is the same as running in the other one.
Okay, it's not crashing, so this is probably just... Maybe I should test instead of run.
But in the meantime, it might you can try to install SBT separately using brew.
Can someone give me the command for that for the terminal, if possible?
I'll put it in the chat.
What's the command to stop something in this thing? Is it Control C?
Yeah.
Yeah, cool. I should do test instead.
Oh, it said it was running. You had it.
Yeah, I just stopped it because I
great.
just wanted to run some tests, and I guess this is it now, so I'll stop screen sharing. I'm gonna...
Great, nice one.
Yeah, thank you so much.
That's right. Anyone else having trouble?
Do you want to share your screen, Jennifer? You can see if we can help you through.
We love failing tests.
Yes.
Okay, so I'm gonna just kick off exercise 1, so at least those of you who are ready to go can start working on it, and then we can help anyone who's not ready once we've kicked it off. So I will share my screen again. So a structure we use a lot in Scala is a list, and it's just an immutable sequence of elements, and a list has a type, and every element in the list must be of that type. And then there's 2 methods on a list that we're going to learn about. And the first one is map. So map, basically you give it a function and it applies it to every element in the list. So here we've got a list of 1, 2, and 3, and we map a function which says take x and multiply it by 2, and we ended up with a list of 2, 4, 6. And then the second one is the filter method. So takes a predicate, which is just a function that evaluates to true or false, and it keeps the item in the list if it passes the filter. So here we're filtering for numbers less than 5. So when we apply this to a list of 4, 5, 6, then we get 4. And I will just show you inside the project what we're going to be working on. So there's a file called exercise1.scala, and there are some example functions. So this one takes a list of people, and person is a case class, and you can click Command B or Control B, depending on Mac or not, on anything, and it will take you to its definition. So we can see here that a person has a name and an ID, and we're just mapping a person to its ID and returning a list of integers. And for the filter one, we're taking a name and a list of people, and we're filtering if we keep the person if the name matches. So the ones with the question marks, what we'd like you guys to implement. And there is a get product function which takes an ID and filters the list, so it just returns products with that ID. And then we want to transform a list of likes which have a product ID into a list of integers. And then our stretch exercise, we have a list of products, and each product itself contains a list of images, and there's something called flat map, which you can use, and you will end up just with a list of strings, but that's just a stretch, so don't worry if you don't get onto it. So is now a good time to split into breakout rooms?
Yep, absolutely. So we've got 16 people. Should we go into groups of 4? I'm just going to see. Let's go into groups of 5, and that'll work. And then I will sort that out now. And then Frankie and Ferdy, I'll put you in 2 different rooms.
Okay.
Am I in the list? I can't tell. Okay, all the rooms have just been assigned.
Have you worked with Java before, yeah?
Yes.
Okay, cool. Cool, you're the right person to have in my breakout room, good.
Hello. Hey.
You're right.
Charlene.
Hey.
How's it going?
I'm going to attempt to be useful somehow.
Thanks. Oh, wait.
I've never touched Scala before, but I have touched Java, so hopefully.
Yeah, exactly same thing as me.
Yeah, no Java for me, unfortunately.
Mm-hmm.
But I think I'm getting the gist of Scala so far.
Yeah, I think it's based on Java, isn't it? So.
Yeah, well,
and they all kind of look the same after a while.
It looks quite similar to Python, which is what I know. So
cool.
It should be okay.
Jennifer, what happened with your machine? I know you restarted, didn't you? Okay, so how are you getting on now? Okay, cool. Solange and Angela, are we? I was paying attention. What's the exercise that we're doing?
Okay, let me share my screen maybe. Okay. Oh, but I've already implemented, so I'm not gonna.
Are we all back again?
I think so, more or less.
Yeah, I think we're all back.
Yeah. Cool. Then we're going to look at options. An option is similar to a list in that it's a container for values. It can contain either a single value or no values. It can be used to, if we have a value, we wrap that value in a sum. And if we don't, that is represented by the object none. You can see an example here. We instantiate a option of an integer by putting 1 into a sum. We use this to say that for certain operations, it's not defined for all the input values, for example. The square root is a good example of that. It's not defined for negative numbers. So if the input number is negative, we evaluate to none, and otherwise we put the value in sum. And similar to a list, we have the map, which allows us to give it a function, and that function will be evaluated for the value if it's present, giving you back another option with the result of that function. And it also has a filter. You can give it a predicate. If the value is present and the predicate holds, then the resulting option stays the same. Otherwise, it evaluates to none. But this way, you can keep operating as if the value was there without having to do null checks or without running into null pointer exceptions. Now we're going to go into the next exercise, and I have to open the correct window. So for the first exercise, for the first part of the exercise, here we show you that you can make some instances of an option. And we have the square root from the slides, but an operation similar to square root in that it's not defined for all the input is division. Division is not defined for divide by 0. So we want you to create a version of division where you give back an option, and dividing by 0 should result in a none. Let's split back up into breakout rooms. And oh wait, I've only introduced the first exercise. And as the last part of the introduction, we showed that you can do map and filters again, just like with the options. Here we might have Steve, or maybe we don't have Steve, and we can give that a function mapping to the name. which should result into the option of a string, to the option of maybe Steve's name or nothing. You can define a predicate to see if the name has spaces and check if there is a middle name. If Steve doesn't have a middle name, it will be none. Or if Steve wasn't there to begin with, it's a none. And otherwise, we still have his name. Using these examples, we want you to, for a product, write the function that if the product has images, there should be images, we want you to return the product ID. And as a stretch exercise, we have a function that is parsing a string to an integer. The default implementation throws an exception, but it's not very nice to work with exceptions. So we want you to write a version that returns an option in case the string cannot be represented as an integer. Let's break back up into breakout rooms to go through these exercises. Hello, is this the breakout room or am I just not seeing the invitation?
You're still in the main room. Christy and Pat, are you able to see the breakout room invitation? Pat and Christy, are you there? Ah, cool. Christy?
Cool. I think this is the time where we planned for a little break.
Oh yeah, that's true. Do people want a break?
Yeah.
Okay. Should we come back in about 10 minutes?
Okie doke.
Cool. And feel free to keep working on the exercise, and it might be away for a bit to grab some.
Okay, lovely. So going back to lists, the way it's actually implemented in Scala under the hood is like a linked list. So a non-empty list has a head, which is just a single element, and then it has a tail, which is kind of a pointer to the remainder of the list. So it's implemented recursively, and the list type is represented by this sealed trait. And you can think of this case class, this is the double colon, is called cons. You can think of this as like a non-empty list, and then the empty list is represented by the object nil, because there's only one instance of that. And you can use this cons operator to build a list. So you can say that one cons nil is the same as a list with just one element in it, which is 1, and you can kind of use it to prepend an element to the list, and that will return a new list with your prepended element at the beginning. And we have this technique called pattern matching in Scala, which is a little bit like a switch statement. So we've got a function here, second followed by 0. So its input is elements, which are a list of integers, and it returns an option of an integer. And it's matching on elements, which is the argument given to the function. And we say, if elements exactly matches this pattern, where there's some element first that we don't care about, then a second one, then 0, then the empty list, which basically means there's no more list, then we return the second element, and otherwise we return none. So for our exercises, in the examples, we've got a load more examples about how you can match on lists. And we also have this concept of a sealed trait. So we have our sealed trait fruit, which is basically like a type. And we've got bananas and oranges and apples, which are all of type fruit. And we get given fruit as an input to the function. And we say fruit match. And then we have a case for each kind of fruit. And we return true for our favorite one. And because it's a sealed trait, you're telling the compiler that it's not going to be extended anywhere else. And that means that if you forget to include a case, then when you try and compile, the compiler will warn you like, hey, you forgot about oranges. So it's quite useful. So the exercises are, we would like you to take a list of products and return the first element in the list, as long as it's not empty. And if it's empty, then return none. And then the second one, we've got an operational result type, and we'd like you to return true if the operation was success and failure otherwise. And then the stretch exercise is pattern matching on what's contained in the case class itself. So yeah, let's get started.
Have to be smaller in size, so it could still be an array. In reverse, we can again traverse the data structure. If we have an empty list, that evaluates the empty list. And if we have more, we take the head and the tail, and we put it back together in the reverse order. So that's the reverse of the tail, and then the head, which results in the reversed list. And it doesn't have to be reducing the size of the problem doesn't have to be traversing a data structure. In factorial, for example, which is often written as exclamation mark and then a number, that is combined. The base case is 1, and otherwise we combine the number with the factorial of the number minus 1. And we've got a couple of exercises around this issue. As Frankie says, it's getting a bit late, so let's just give them as homework.
And we're hiring.
Amazing. Thank you so much. I hope everybody had a really good time. I think it was really good to see some Scala and see how you can use it. And I heard a few people say that they loved it being test-driven as well. So fantastic. Thank you so much for that. If anybody does want to find out more about Depop, they also have a company profile on the Coding Black Females website where you can find out more about them and also see the diversity statement and everything else as well, and the roles that they've got open too. And obviously pop over to their job board and find out everything they've got open at the moment. But thank you so much. It was a great session. We really enjoyed it. I have recorded quite a few bits of it. So the bits that aren't in breakout rooms are recorded. So hopefully we'll have more people getting involved as well. Yeah, thank you so much.
Thank you for joining.
Thanks, Aline.
Thanks.
Yeah, thanks everybody for joining.
Thank you.
Where is the slides? Do I have them here? I'll try and send the slides in the...
Amazing. Thank you so much. That'd be really useful.
Is this the one? Yeah.
Nice one. Awesome. And we also get the slides. So thank you very much. That's awesome. Enjoy your evenings, everyone. I know it's kind of late, but it was fun. So, and enjoy your evenings too, Frankie and Ferdy. Like, thank you so much. Honestly, I think everyone really enjoyed that. So,
Yeah, it was fun. Thank you.
Bye.
Thank you. Thanks for joining.
Bye.
Thank
Bye.
you.
Thank you.
Thank you. Bye.
Thanks, everyone. Have a good night.
You too.